Welcome back to Roland Tutoring. If this is your first time joining us, please take a moment to hit the subscribe button. Today we are looking at a fluid mechanics problem. The problem statement is as follows. Calculate the density, specific weight, and specific volume of air at 120 degrees Fahrenheit and 50 psi. So the first thing we will need to do is flip back to your appendix here in your book. I'm not sure where that will be in your specific book, but you'll need an appendix that gives you the properties of gases at standard sea level and atmospheric pressure. So you can see it's in Fahrenheit, so we'll find the table that shows us degrees Fahrenheit. And then we'll look over for our gas constant, and we are looking for air here. So we can come across and find that our R for this one is going to be 1715. So we will copy that down. R equals 1715. And then we can go ahead and get started. Alright, so once we have that, get our book out of the way here, we will use our equation from our equation sheet of perfect gases. We'll use this equation again to find our specific weight before we find our density and volume. So we can go ahead and fill in our specific weight equals our G, which will be 32.2 in this case, times our pressure, which in this case was 50 psi, which we will need to convert to pounds per square foot, so 50 times 144. And we'll put all of that over R times T, which here we have our R, we have 1715, times our T of 120 plus 460 to get into degrees ranking. We'll plug that in to our calculator here. 32.2 times 50 times 144 divided by 1715 times 120 plus 460. And that should give us 0.233. So that is your first answer here, 233 pounds per cubic foot. And that is our specific weight. So that is the first of three answers that you will need. Next, we need to find density and the specific volume. So we'll have to go back and look at our equations again, because we will need to find an equation for density, which we can also look at. We have pressure over density equals RT. So in here we have 1, 2, 3 variables, so we can use that one. And the volume we can also use, we have pressure times volume equals RT. And these are all equations. If I pull out our equation sheet again, these are just pulled from the book of our perfect gas laws here. We have pressure, density, pressure, volume, our constant times our temperature. And again, remember your temperature should be ranking or Kelvin. In this case, we're in Fahrenheit, so it should be converted to ranking. We go ahead and put that in. Again, we are solving for this, so we actually have P over RT gives us our density. And in this one, we want our volume, so we can say volume equals RT over P. So our R, again, will be this constant of 1715 times our temperature, which if we add that together should be 580. And our pressure, since our R values are listed in feet, we will need to convert our pressure back to feet again, which is why we do 50 times 144. If we go ahead and plug that one in now, 50 times 144 divided by 1715 times 580, and that should give you 0.00723, or 724 if we round up from this 8. And this turns into slugs per foot cubed. And again, you'll just want to follow your units. If you're having trouble with that, I would recommend writing your units behind each one of these. So you could say pounds per inch squared times inch squared, which will leave you with pounds. And then we have degrees ranking here, and our unit for R. Grab that again. We have feet, foot-pound per slug, degree ranking. So our ranking crosses out here. We have a pound on top, so we get that, which then turns into our slug comes on top and becomes slug per foot cubed. So that is our second answer. Final answer will be our volume equals our constant times temperature divided by pressure. We get 1715 times our 580 over our 50 times 144. If we do that here, we get 1715 times 580 divided by 50 times 144, and you get our volume is equal to 138.2. Just rounding up here again, round up according to your course requirements, but this one will actually be feet cubed per slug. That will be our final answer. And if you look closely, we're doing basically the opposite of what we did to get the density, because our volume does equal 1 over our density if you've looked at the other equations. So that would mean our units just flip. If you need more help, that finalizes our answers there. If you need more help in fluid mechanics or any other course, or would like to have your problem solved, please reach out to us. We do offer one-on-one tutoring, and we would love to feature your problem on our channel. Reach out to us. We can be contacted in the methods listed in the video description. And if you haven't already, please hit the thumbs up button and subscribe, and have a wonderful day.